Hello sir, my name is K. Harshavardhan. I am from CSM section and I am here to present my video about topic decoders and multiplexers. So sir, now in this video presentation we will discuss about decoders and multiplexers. This we are going to know about the what is decoders and types of decoders, how decoders works and the types of decoders works and what is multiplexer and types of multiplexers are there and how multiplexers works and the decoders and multiplexers. So in this video presentation we are going to discuss this. Now in this video we are going to discuss about introduction to decoders and multiplexers. Decoders and multiplexers are essential in the detailed logic components. For the electrical engineering, there is a separate means the connection explanation will be mostly happen in detailed electronics. The detailed logic is the most used components are the main decoders and multiplexers only. These are the various electronic systems. They facilitate data routing, conversion, processing within detailed circuits. Means they will only works on the binary digits means 0 or 1. For the 0 or 1 we are going to make this data operations on the data routing, conversion and processing by using these decoders and multiplexers. These are used for this purpose only, routing, conversion and processing. Understanding their functions is crucial for designing efficient digital communication and computing system. So design the efficient digital communication, we are have to understand those functions and what are the and what are the multiplexers and how. So we are going to discuss about this in the slides. Now in this slide we are going to discuss about the what is a decode. Decode is a combination circuit that converts binary information from n input lines to a maximum for n unique out lines. Means when we give the n input lines means 2. If we take the example for example n equal to, then the outcomes will be means the outputs will be over n means 2 square 4 means if we give the two inputs two input lines 0 and 1 so that x y, then we get the outcomes 4 outputs means 2 per n 2 square. So it actually decodes the binary input into a one hot signal means decoder in the name itself has means we are going to decode that binary into a one hot signal. Decoders are commonly used in data demultiplexing, memory address decoding and detailed display system. Decoders means here we discuss about data demultiplexing and memory address decoding and detailed display system. These are the applications we are going to apply the decoders method. So in this slide we are going to discuss about the types of decoders. We learned that the decoders when we give the n input lines we get the 2 per n outputs. So based on those the decoders are divided into some types. So the most common decoders include 2 4 means 2 input lines and 4 outputs. 3 to 8 3 means we are going to give the 3 inputs and 2 power 3 equal to 8, so we get the 8 outputs. And 4 to 16 same, power 4 equal to 16 decodes based on the number of inputs and outputs. Each type of decoder is designed for specific applications requiring different data conversion scales. Decoders can also be combined to create complex decoding functions for advanced digital systems. And now, how a decoder works. When a specific binary input is received, the decoder activates only the corresponding output line. All other outputs remain inactive, ensuring precise data routing. Means when the binary input is received, the decoder activates only the corresponding output. Means the corresponding output line which is given in all other outputs. The remaining outputs become inactive. Means they will doesn't participate in this combination circuit. So this selective activation allows decoders to be used for address decoding and control signal generation. So here these decoders are used for address decoding and control the signal generations. And now we are going to discuss about multiplexer. A multiplexer, also called as MEX, is a device that selects one of many input signals and forwards it to a single output line. Means it is opposite to the uh, Decoder. Decoder, we will give the n inputs and we will get the 2 power n. But here we will get the, when we give the multiple input signals and we will get the, so it is a multiplexer. It acts as a data selector controlled by select lines that determine which input is passed. Means it acts as a data selector. Means which input is passed, we are going to find out by this multiplexers only. Multiplexers are fundamental in data routing, signal multiplexing, and resource sharing systems. And types of multiplexers here same. One type include 2 1, 2 1, 8 to 1, 16 to 1 multiplexer. Here all out compulsory will be the only one, and inputs may be any number of inputs get the only one out based on the number of inputs. The number of select lines increases logarithmically with the number of inputs. Multiplexer can be combined to manage larger data sets or multiplex selection area. And now we are going to discuss about the how a multiplexer works. The select line determines which input is connected to the output at any given time. Means whatever the line we selected, here which input is connected to the output at any given time. When a particular select line combination is active, the corresponding input, this process enables efficient data transfer and management in detailed circuits. Now we are going to learn about the differences between decoders and multiplexers. Decoders convert coded input into a set of output, whereas multiplexers select one input from many. Yeah, we learned about this. Decoders will convert the inputs into but multiplexers select one input from many. Decoders are primarily used for decoding address or control signal, while multiplexers are used for data selection and route. Difference is there. This is used for the decoding purpose, but here it is used for selection. Which input line we are getting means which signal is we are getting means we are going to multiplexer. Both components are combinational logic circuits, but serve distinct functions in digital systems. And as we learn about all these applications of decoders and multiplexers now, decoders are used in memory address decoding, detailed displays, and keyboard encoding. Multiplexers are employed in data acquisition systems, communication systems, and data bus management. Both components enhance the efficiency and scalability of digital electronic systems. Yeah, means decoders here used in memory address digital displays. Keyboard multiplexers are used in data acquisition, means getting the data. Acquisition means receiving. Communication systems and the data bus management. Components enhance the efficiency and scalability of systems. And these are the references which we got these multiplexers and decoders. So thank you, sir. I hope you understand my presentation well and I performed so well. So thank you for listening to the presentation. So